All right, let's start by implementing the addLast method. So public void addLast, we give it an integer. Now, what should we do here? The first step is to wrap this value, this integer, inside a node object. So we create a node object like this. Now, as we can see, we have repeated the name of the class twice, and this is unnecessary. We can use the var keyword and let the Java compiler detect the type of this variable. So because we have new node on the right side, the Java compiler will know that this variable is a node object. All right, now we need to set node.value to this item. However, this field is declared as private, and that's why we cannot access it from outside of this node class. We can come here and create a setter like public void set value, which takes a value, and here we type this.value equals value. But I'm going to show you a better way. I argue that this node class is part of the implementation of the linked list. We don't need to work with this node class directly. So this should not be declared as a public class here that can be accessed anywhere in our program. Earlier when we worked with the linked list class in Java, did we see a node class? We didn't. We simply called various methods on the linked list, and the linked list took care of everything under the hood. So this node class is something that the linked list class should have internally. It's an implementation detail. So we can remove this setter and move this class inside the linked list. So we can add it here on the top. There you go. Now, because this class is declared inside the linked list, we have access to its private fields. So we don't need a setter. Also, we should change this to private. So nowhere in our program, we can access the node class. That's better. Now, another thing we need to improve here is this line. With this implementation, we can have a node that doesn't have a value. This doesn't make sense. Whenever we create a node object, it should always store a value. So we can create a custom constructor for the node class and pass this value there. So here in the node class, we type public node. In this constructor, we add a value and we set this.value to value. Now we can get rid of line 18 and simply pass the value here. Sorry, I mean the item. So our code is shorter and our node object will always be in a valid state. We're not going to have a node without a value. That doesn't make sense. So we have a node. What should we do next? Well, that depends on the state of the linked list. If our linked list is empty, we need to set both the first and last nodes, or head and tail, to point to this new node. Otherwise, we need to append this node at the end of the list. Let me show you. So here's the first scenario. We should check to see if the list is empty or not. How can we do that? We write an if statement like this. If first equals null, that means we don't have any nodes in this list, because as soon as we add a node in this list, first should be initialized. So if first is null, we should set first to this new node. We should also set last to this new node, or we can simplify these two lines and initialize both these variables on the same line. That is better. Now we don't need these ugly curly braces. So let's look at the other scenario where our list has at least one node. So else, in this case, we want to add this node after the last node. So we type last.next equals node. We're linking the last node to this new node. Finally, we should update last to point to this new node, because now we have one new node in this list. So we type last equals node. We're done with the implementation of this method. So let's use our new list and see if it's working properly. So back to the main class, I'm going to create a new linked list. We call it list. Now, once again, we can use the var keyword to simplify this code. Here we're going to call list.addLast 10, and then 20, and then 30. Now, currently, we don't have a method for printing this list. And I realized I forgot to tell you to implement this method. But in this video, I don't want to spend time implementing the print method. Instead, I'm going to show you a different technique. So we add a breakpoint on this line by clicking on this area. Look, now it's red. Now we're going to run this code using the debugger. So on the top, look, run, debug main. Here's the shortcut, that's Control and D on Mac. So here we are. All the previous lines are executed, but this line is not. So we can click on this icon, that is step over. Now all these lines are executed. So let's inspect our list object and see if it's structured properly. So in this debug window, let me expand this. Good. So here we have this list. Let's look at the first node. So the value is 10. Now next, this is referencing another node. What is this node? Here we have 20. And this is also referencing another node. In this node, we have 30. But next here is set to null because this is the last node in our list. So far, so good. What about our last node? This is pointing to the same object where we have the value 30. Beautiful. So we're done with this step. We'll implement another method next.